It begins not with a city, but with silence. A silence older than pyramids, deeper than the sea, and etched into the planet itself. If the Earth could speak, its first words after the last ice age would be a whisper of fire and water colliding, continents breaking, oceans rising, and light itself dimming under a veil of dust. Geologists call this epochal rupture the Younger Dryas, a sudden cooling event that began roughly 12,800 years ago. Myths, however, remember it by another name, the Great Flood. Across the planet, cultures that never met tell the same story. In ancient Sumer, the gods warned Utnapishtim to build a vessel and carry the seed of life before the waters rose. In India, Manu saved humankind by tethering his boat to the horn of a divine fish, a symbol that would ripple through later faiths. In the Andes, the god Viracocha emerged from Lake Titicaca after a deluge to recreate the world from clay. Among the Hopi of North America, the spider grandmother led the survivors into caverns until the floodwaters withdrew. These tales, separated by oceans and millennia, repeat the same pattern: destruction, survival, rebirth. For centuries, scientists treated such stories as coincidence. But in the late 20th century, new evidence began to blur the line between myth and geology. Deep beneath the ice of Greenland, researchers discovered a layer rich in iridium and platinum, elements rarely found in Earth's crust, but common in meteorites. The layer coincides precisely with the start of the Younger Dryas. Beneath it lie microscopic spheres of melted rock, impact spherules, and shards of nanodiamonds, both signs of a cosmic collision. Around this same time, massive wildfires swept across North America, and the great mammoths, mastodons, and saber-toothed cats vanished almost overnight. The climate shifted in a single human lifetime. Something, perhaps a fragmenting comet, had struck or exploded above the northern hemisphere, triggering firestorms, floods, and darkness. If Plato's story of Atlantis was more than allegory, it may preserve a cultural memory of that cataclysm, the drowning of coastal lands, the collapse of ice sheets, and the submergence of cities near ancient shorelines now lost beneath the sea. For the first time, science and myth began to speak the same language. And amid that chaos, something astonishing happened. Design survived. From the ashes of extinction, humans began to build, not just shelters, but sanctuaries. In southeastern Turkey, archaeologists uncovered a site that rewrote the story of civilization, Gobekli Tepe. Radiocarbon dating places its construction around 9,600 BCE, more than 7,000 years before the Great Pyramid of Giza. Massive T-shaped pillars, some weighing 10 to 20 tons, stand arranged in concentric circles atop a hill. They are covered with carvings of foxes, vultures, snakes, and abstract symbols, animals tied to constellations, fertility, and rebirth. Long before agriculture, before pottery, before cities, someone gathered hunter-gatherer clans to quarry, sculpt, and raise these stones in deliberate alignment with the stars. The level of planning defies everything we thought we knew. Without metal tools or draft animals, how were such megaliths cut, transported, and balanced? How did nomads organize labor forces large enough to move stone by the ton? And why? Computer simulations of the site's layout show that several of the enclosures mirror the constellation of Cygnus, while others align with the rising of Orion around 10,000 BCE. The same celestial markers later echoed in Egyptian and Mayan architecture. It is as if the builders of Gobekli Tepe were rebuilding a celestial map they already knew, a blueprint of the heavens restored on Earth. Archaeologist Klaus Schmidt, who led the excavation until his death in 2014, called the site a cathedral on a hill, suggesting it was a place of shared ritual rather than daily life. And when it was complete, its creators did something even stranger. They buried it, deliberately, carefully, as though sealing away the memory of a lost age. Why would a people invest generations of labor to create such precision, only to hide it under layers of earth? Some believe it was a sacred burial of knowledge, a vault of the first civilization, preserved against another flood or fire. Others think it was an act of closure, a symbolic entombment of grief for a world destroyed. Whatever their reason, the message endures. Gobekli Tepe forces us to reconsider what civilization means. Perhaps it does not begin with farming or writing, but with memory, with the need to rebuild meaning after catastrophe. The stones whisper a possibility, that the humans who raised them were not inventing civilization, but remembering it. Their geometry, their symmetry, their astronomical alignments are too refined to be chance. They suggest an inheritance, a continuity passed not through bloodlines, but through observation, storytelling, and stone. If the Younger Dryas erased a global culture, then Gobekli Tepe may be its echo, a monument to memory itself, carved by survivors who still remembered the stars. And so the question returns: was civilization an accident of evolution or a reconstruction of something the Earth had already known? When the last frost of the Ice Age melted, rivers surged and deserts bloomed, the survivors scattered, carrying fragments of geometry, myth, and skyward longing. In time, those fragments would converge again, on the banks of a river that flowed from the heart of Africa to the stars. There, a new kingdom would rise, one that called itself the heir of the first time, the era before the flood. It would carve memory into limestone and align its monuments with the heavens once more. And through its precision, it would tell us that humanity was not beginning anew, but remembering what the earth had taught it once before. The first light of dawn over Giza cuts through the desert like a blade, cold, golden, and perfect. The sand glows with the color of ancient fire, and the shadows of the pyramids stretch for miles across the plateau. Even now, their edges remain mathematically sharp, their faces aligned so precisely to the cardinal directions that modern surveyors still marvel at the error, less than 1/15 of a degree. We are told this is where civilization began, that Egypt rose suddenly from the desert, a miracle child of the Nile. But what if this was not the beginning, but the memory of something that came before? The Egyptians themselves said as much. In their oldest texts, they spoke not of invention but of inheritance, of Zep Tepi, the first time, when gods walked beside men and taught them the laws of order, architecture, and the sky. Pharaohs described themselves not as founders, but restorers of the knowledge of the ancients. Their monuments, they claimed, were built in the image of the first temples, copies of prototypes buried long before their reigns. At the heart of this legacy stands one enigma above all, the Great Pyramid of Khufu. Built with over 2.3 million limestone and granite blocks, some weighing up to 80 tons, it rises with a precision that defies its supposed age. Each side measures nearly 230 meters, yet the difference between the longest and shortest sides is less than 5 centimeters. The entire structure once gleamed white with polished Tura limestone casing stones, so bright it reflected sunlight like a beacon. Its alignment to true north remains nearly perfect, achieved without compasses or magnetic tools. Recent measurements by satellite and laser scanning confirm that the builders oriented it by observing the rotation of the stars, specifically the circumpolar constellations of Kochab and Mizar around 2500 BCE. To track such motion required an understanding of precession, the slow wobble of Earth's axis, a concept officially discovered only in 130 BCE by Hipparchus. Inside, the pyramid's grand gallery ascends at a precise 18 degrees, its corbelled ceiling forming a sound chamber of acoustic perfection. When tested by engineers, its resonance amplifies sound frequencies at harmonics consistent with Earth's natural Schumann resonance, 7.83 Hz, To some researchers, including acoustic physicist Tom Danley, this is evidence that the structure could act as a resonant cavity, capable of converting low-frequency vibrations into standing waves. Egyptologists remain cautious, calling it coincidence, yet the geometry feels too deliberate to dismiss. Mathematically, the pyramid also encodes the curvature of the Earth. The ratio of its height to its base equals 2p, suggesting that the builders understood the planet as a sphere, 2,000 years before Eratosthenes calculated its circumference. The ratio of the pyramid's height to the radius of a circle drawn around its base produces the same relationship between Earth's radius and its equator. Whether symbolic or intentional, this geometry reads like an ancient formula. The Earth rendered in stone. And then there is the Sphinx, a riddle carved in silence. Half lion, half human. Its body bears erosion not from wind or sand, but from rain. In a desert that has not seen sustained rainfall for thousands of years, this weathering is out of place. In 1991, geologist Robert Schoch of Boston University argued that the vertical fissures on the Sphinx's body could only have been caused by precipitation over centuries, implying an age closer to 10,000 BCE when the Sahara was still green. If true, the Sphinx would predate dynastic Egypt by millennia, possibly belonging to a forgotten epoch when the Nile Valley was wet, fertile, and alive. The head complicates the story. It is disproportionately small for the body, a detail unique in Egyptian art which otherwise maintains perfect symmetry. Some scholars, including independent researcher John Anthony West, suggested it was recarved from a larger lion's head, reshaped into the likeness of Pharaoh Khafre. If so, the Sphinx would be a monument spanning two worlds, born in one civilization and adopted by another, a palimpsest of lost time. Beneath the Giza Plateau, myth speaks of the Hall of Records, a legendary archive said to contain the wisdom of the gods, or the survivors of a pre-flood age. While mainstream archaeology finds no direct evidence, ground-penetrating radar surveys conducted in the 1990s by the Stanford Research Institute and Egyptian Antiquities Organization did reveal anomalous voids, large, symmetrical cavities beneath and around the Sphinx. Whether natural or man-made, they remain unexplored by official excavation. Could Egypt's Golden Age have been built not upon invention, but upon inheritance? Knowledge passed down through oral memory, myth, or even physical structures that predated the pharaohs. If Gobekli Tepe shows that megalithic design existed 6,000 years before the pyramids, then the line between prehistory and civilization becomes thinner than we thought. Egypt's brilliance extended far beyond stone. Medical papyri, such as the Ebers Papyrus 1550 BCE, reveal a sophisticated understanding of anatomy, circulation, and surgery. Physicians performed cranial trepanation, treated fractures with wooden splints, and used honey and mold, natural antibiotics, to prevent infection. Artificial toes found in burial sites near Luxor have been confirmed by modern orthopedic studies as functional prosthetics capable of restoring balance and motion, proof of applied biomechanics thousands of years before the term existed. Their chemistry, too, was advanced. Mummification required mastery over natron salts, resins, and essential oils that preserved tissue for eternity. The ancient word for embalming, wabet, meaning to purify, suggests that preservation was a form of sanctified science, not superstition. In their cosmology, to keep the body intact was to keep the soul anchored, a biological philosophy centuries ahead of its time. To the Egyptians, wisdom was never self-created, it was received. They credited their arts to Thoth, the god of writing and measurement, said to have inherited his knowledge from the gods before him, an infinite regress of memory echoing through eternity. Their civilization was not born in ignorance, but born from the ashes of remembrance, the first to restore order after the chaos of the flood. Perhaps that is Egypt's true genius. It was not the first to invent, but the first to remember, to translate cosmic proportion into architecture, to turn myth into mathematics. And across the sea, in the mountains of Lebanon, lie stones larger than any at Giza, carved with precision no less astonishing. In the heart of Lebanon, where the Bekaa Valley stretches between mountains like a scar carved by time, stands a city of stone that defies explanation. This is Baalbek, once known to the Greeks and Romans as Heliopolis, the city of the sun. Its ruins still dominate the landscape, colossal columns rising toward the sky, broken arches glowing gold under the Levantine light. But it is not the beauty above ground that stirs the imagination. It is what lies beneath, the foundation stones, older and larger than any known in antiquity, blocks so vast they seem to mock the very idea of human limitation. The Temple of Jupiter, centerpiece of the Roman complex, sits on a terrace of 3 stones, each around 800 tons, perfectly cut and placed with no visible gaps. These are known as the trilithon, and they rest upon smaller blocks weighing 300 to 400 tons each. To stand beside them is to feel an almost physical disbelief. Their sheer size dwarfs everything, the visitor, the columns, even the notion of scale itself. And in the nearby quarry, a short walk downhill, the marvel continues. There lies the stone of the pregnant woman, or Hajar el-Hibla, a single limestone monolith estimated at over 1,000 tons. It was discovered lying at an angle, as if its transport had been interrupted mid-lift. For centuries, this stone was considered the largest ever quarried by human hands. But recent excavations uncovered another block, still embedded in bedrock beneath it, the so-called Stone of the South, weighing an estimated 1,200 tons. And deeper still, a third, even greater block, the Forgotten Stone, calculated to weigh over 1,600 tons. No crane of the Roman world, not even the ingenious treadwheel hoists used in their greatest amphitheatres, could have lifted such masses. In fact, even modern industrial cranes struggle to move a single block of this size without cutting it into sections. Yet here they are, quarried, shaped, and aligned as though the builders possessed technology that combined precision, stability, and foresight far beyond what history records. Archaeologists have long debated their origin. Mainstream explanations suggest that the lower terrace predates the Roman construction above it, perhaps the foundation of an earlier, local sanctuary dedicated to Baal or Hadad, later incorporated into the Roman city. But the weathering patterns complicate that story. The erosion on these megalithic blocks is visibly older than the Roman temples they support, suggesting that the Romans built atop a pre-existing platform. The age of that earlier structure? Unknown. Its builders? Forgotten. Why such impossible stones? Some propose practical motives, a massive base to stabilize the soft alluvial ground beneath. Others see symbolism, the use of impossible weight to glorify the gods, to fix heaven and earth in a single axis of power. Yet others detect something subtler, resonance. When viewed from above, Baalbek's layout forms a near-perfect alignment with solar and lunar events. The platform's long axis points toward the rising sun of the summer solstice, while its lateral walls capture the movement of shadows during equinox. To ancient eyes, this was not random geometry, it was cosmic calibration. The temple, they believed, was the sun's landing place on Earth, a place where divine energy could be anchored through mass, symmetry, and vibration. Some modern engineers, studying Baalbek's structure, have proposed an extraordinary idea, that the platform's immense stones were not merely foundations, but part of an energetic or seismic dampening system. Their density, shape, and interlocking fit could stabilize the entire structure against earthquakes, a crucial advantage in a region of tectonic volatility. Others go further, suggesting that such massive, harmonically balanced stones could have acted as resonant amplifiers, transmitting or absorbing natural frequencies from the Earth's crust. The idea may sound speculative, but the phenomenon of singing stones, low-frequency hums generated by wind or vibration, is real and measurable. At Giza, Tiwanaku, and even Stonehenge, similar acoustic effects have been recorded. Could Baalbek too have been tuned to the voice of the earth? Its ancient name offers a clue. Baalbek means city of Baal, Baal being the Semitic god of storms, lightning, and fertility, a deity who ruled through thunder. If Baal was a god of vibration, of energy descending from the sky, then Baalbek was not merely his home, but his conductor. The Romans later reinterpreted Baal as Jupiter, the god of thunder, preserving the association. And thus, what had once been a temple of energy became a temple of empire. Myth agrees with the mystery. Arab and biblical legends claim Baalbek was built by giants under King Solomon's command, or even by the Nephilim, hybrid beings from the age before the flood. Medieval writers described it as Nimrod's fortress, the last refuge of a world destroyed by divine fire. Such stories, though mythic, point backward, to a memory of power so immense that it could raise mountains and anchor them in stone. Modern aerial photography adds another layer of intrigue. From the sky, Baalbek's terraces and chambers resemble a circuit diagram with repeating patterns and right angles more reminiscent of engineered blueprints than religious art. It is tempting to imagine the entire site as part of a larger system, architectural, energetic, or symbolic, designed to mirror celestial order on Earth. And if such knowledge once existed, the art of shaping stone through balance, vibration, and geometry, then it did not end here. Across the ocean, another civilization built walls so tight that even a knife blade cannot slip between their stones. The Andes rise like frozen waves along the spine of South America, a continent stretched between sky and fire. Up here, above 3,000 meters, the air grows thin, the light sharp as crystal. The snowcaps glint like mirrors to the heavens. It is a landscape of extremes, and yet against all odds, the ancients made it their home. They did not merely survive the mountains, they sculpted them. The Inca called their empire Tawantinsuyu, the 4 quarters of the world. It was the largest civilization of pre-Columbian America, stretching from Ecuador to Chile, its roads spanning more than 30,000 kilometers, an engineering feat rivaling Rome's. But what truly endures are the stones, silent, unyielding, alive. At Sacsayhuaman, just above the city of Cusco, the stones rise in lightning-shaped walls, massive zigzags of diorite and andesite, so perfectly fitted that not even a sheet of paper can slide between them. Some blocks weigh 120 tons, cut with complex polygonal edges that interlock in irregular patterns. There is no mortar, no cement, no binding agent, only balance and geometry. Archaeologists explain it through hammerstones and patience, but the rock here is harder than any tool the Inca possessed. Bronze chisels could not have cut it, copper would have shattered, and yet every surface curves slightly, as though moulded while still soft. Some modern researchers note strange vitrification, a glassy smoothness along certain joints, suggesting intense localized heat. Whether from friction, fire, or lost technique, no one can say. Others speculate about sonic shaping, the use of vibration to loosen stone, a concept that sounds fantastical until we recall that resonance, sound affecting matter, is a known physical principle even today. Whatever the method, the outcome is unmistakable. Walls that move with the earth. When earthquakes strike, Sacsayhuaman does not fall. Its interlocking stones shift, absorb, and settle back into place. This architecture behaves like a living body, flexible, resilient, aware. In Cusco and Ollantaytambo, the same system repeats. Blocks carved to fit together like puzzle pieces, dispersing seismic energy through irregular seams. Across the cliffs and canyons, they wove bridges of grass. The Tiwanaku Bridge, suspended over the roaring Apurimac River, is rebuilt every year by the descendants of the original engineers. Entire villages gather for the ritual. From ichu, a local highland grass, they braid thin ropes into thick cables, tensioning them across a span more than 30 meters long. The bridge holds travelers, livestock, and the weight of centuries. It is a miracle of design, but also of memory, the fusion of community, rhythm, and repetition. Each knot is a formula, each movement an equation lived rather than written. Their technology reached into the mountains themselves. Where others saw barren slopes, the Inca saw potential. They carved the earth into terraces, green stairways of fertility that transformed altitude into agriculture. At Pisac, terraces hug the mountainsides like contour lines drawn by a cosmic surveyor. They collect rainwater, control erosion, and create microclimates. And at Moai, the innovation becomes breathtaking. Concentric terraces descend 30 meters deep, forming a circular amphitheater. Scientists measuring temperatures at different levels found variations of up to 5 degrees, enough to grow entirely different crops in each ring. Moai was not a farm. It was a laboratory, an ancient experiment in agricultural science. They mastered water too. The Andean world is a paradox of abundance and scarcity. Glacial melt meets arid plains. The Incas turned this chaos into balance. At Tipon, a network of canals, aqueducts, and fountains still flows today. Water guided through precision-cut channels that never spill, never flood. Hydraulic engineers from the 20th century marveled that its distribution system maintains a constant flow rate despite changes in elevation, evidence of pressure regulation far beyond primitive trial and error. And then, hidden between peaks where clouds gather like oceans, stands Machu Picchu, the lost city of the sun. Perched nearly 2,400 meters above sea level, it appears weightless, as if resting between worlds. Its buildings align with solar and stellar events. On the solstice, sunlight pierces the Intihuatana, a carved granite pillar marking the moment the sun ties itself to the earth. The terraces below are both beautiful and functional. They stabilize the mountain and drain excess rainwater through gravel layers that prevent landslides. Spring water from nearby peaks was channeled through 16 stone fountains, still functional today. Archaeologists have reconstructed its layout and found it to be mathematically precise. Its ratio of height to width follows the golden mean, echoing the harmony found in natural forms. No mortar was used, yet the joints are so exact that the city has survived earthquakes, storms, and centuries of neglect. The Spanish conquistadors never found Machu Picchu. It escaped conquest not by strength, but by secrecy. Some believe this was intentional, a sanctuary of scholars, astronomers, and engineers safeguarding the knowledge of the empire's ancestors. In a way, it was more than a city. It was a repository of alignment, both physical and spiritual. The Inca worldview saw no division between stone and soul. To them, the world was animated. Every mountain, every river, every block of granite possessed a living essence called kamak. To carve stone was not to dominate it, but to awaken it. Every wall, every terrace, every bridge was a conversation, a dialogue with nature conducted in geometry and time. Their legends reach even farther back, beyond history. They speak of Viracocha, the great teacher who came from the sea after a flood that ended the previous world. He taught humans how to build, to farm, to measure the stars. Then he walked west, across the ocean, promising to return. In his description, bearded, cloaked in white, radiant with light, he mirrors the figures of wisdom from other ancient cultures. Thoth of Egypt, Enki of Sumer, Quetzalcoatl of the Maya. Was he a memory of real survivors from a pre-flood civilization? or simply the universal image of humanity's lost teachers. And somewhere beyond these summits, across jungles thick with mist and time, another civilization was watching the same stars. They too turned heaven into a map and sound into science. Where the Incas built harmony into stone, the Maya would teach the world to listen to the sky. In the dense jungles of the Yucatan, night falls like velvet, heavy, alive, eternal. Between the cries of howler monkeys and the rustle of unseen wings, the air seems to vibrate with memory. Above, the stars blaze sharper than in any city sky, forming patterns that ancient eyes once knew by heart. Here, among the trees and limestone plains, the Maya built not just cities but instruments, architectural symphonies that sang to the heavens. At Chichen Itza, the pyramid of Kukulkan rises from the jungle like a mathematical prayer. Each equinox, the late afternoon sun falls across its northern stairway, forming a serpent of light that slithers down the steps, an illusion so precise it lasts for only a few minutes each year. As the serpent of shadow descends, it connects heaven and earth, symbolizing the god Kukulkan, the feathered serpent, bringer of knowledge and renewal. But light was not the pyramid's only language. Sound, too, was built into its design. When a visitor claps at its base, an echo returns, sharp, melodic, unmistakable, the chirp of the quetzal, the sacred bird whose call symbolized divine presence. Acousticians from the University of Texas and the National Autonomous University of Mexico have tested the pyramid and confirmed that this was no coincidence. The step height, angle, and porosity of the limestone combined to shape the echo into the quetzal's frequency. Through geometry, the Maya made stone sing. Their world was one of harmony, not hierarchy, a civilization tuned to the cycles of sky and earth. They built El Caracol, the snail observatory, a circular tower within Chichen Itza, whose narrow windows align with solstices, equinoxes, and the rising and setting points of Venus. For the Maya, Venus was no ordinary planet. It was the celestial twin of their hero god Kukulkan. Its cycle of 584 days guided wars, coronations, and rituals. Without telescopes, they measured the heavens through shadow and repetition, achieving calculations of the solar year within 0.002 days of modern accuracy. Their concept of time was a living thing, not linear, but cyclic, breathing. The Tzolk'in, the 260-day ritual calendar, the Harb, the 365-day solar year, and the long count, spanning thousands of years, meshed together like gears in a cosmic clock. Every 52 years, these calendars aligned perfectly, a sacred renewal known as the binding of the years. Fires were extinguished and rekindled to mark the world's rebirth. When the long count calendar completed a great cycle in 2012, the modern world panicked, imagining apocalypse. But to the Maya, it was no end, only another revolution of the wheel, another heartbeat in the eternity of time. This reverence for order extended into every aspect of Maya life. Their cities were cosmic models, each plaza, pyramid, and temple aligned to celestial events. At Tikal, in modern Guatemala, twin pyramids mirror each other across a plaza, so that during the solstices, one casts a shadow directly onto the other's stairway. At Uxmal, the Pyramid of the Magician rises on an elliptical base, a rare departure from symmetry, oriented precisely toward the setting sun on the equinox. But the Maya were not only astronomers, they were also hydraulic engineers of astonishing ingenuity. The Yucatan Peninsula lacks rivers, yet their cities flourished in the dry limestone basin. At Calakmul and Tikal, vast reservoirs collected seasonal rains, lined with clay and sealed with quartz sand that filtered impurities, an ancient form of water purification technology. At Edzna, elevated canals carried water to crops, while sluice gates controlled flooding. These systems kept tens of thousands alive for centuries. proof that to know the heavens was also to command the earth. Even colour held cosmic purpose. The famous pigment Maya blue, used on murals and ceramics, baffled chemists for decades. Unlike ordinary dyes, it never faded, even after 1,000 years of humidity and sun. Researchers eventually discovered that the pigment was created by heating indigo dye with a rare clay called palygorskite at a precise temperature of about 200 degrees. The molecules fused, forming a hybrid organic-inorganic compound. It was a chemical bond so stable that it resisted acid, sunlight, and time itself. The Maya had, in essence, achieved a form of nanotechnology, a dialogue between chemistry and art far ahead of its era. But perhaps their most mysterious mastery was of acoustics. At Uxmal and Palenque, archaeologists have recorded focused sound transmission, whispers carried across courtyards, echo patterns that amplify chants in ritual chambers, and even low-frequency hums within certain temples that match human vocal resonance. To speak within those walls was to commune with the gods through vibration. Their cities were not inert, they were alive, instruments that responded to voice, wind, and light. This union of engineering and cosmology reveals a worldview where architecture was not separate from spirituality, but its vessel. And yet, for all their precision, the Maya left behind one of history's greatest mysteries: their sudden disappearance. By the 9th century, the great urban centres of the classic period, Tikal, Copan, Palenque, were abandoned. There was no singular catastrophe, no evidence of foreign invasion. Climate records suggest cycles of drought. Pollen samples indicate deforestation and soil exhaustion. Some scholars see this as ecological collapse. Others view it as spiritual renewal, the deliberate withdrawal from cities when an age had ended. Perhaps, as their mythology suggests, the world had simply turned again. Civilizations rise and fall as the stars do, each returning in a new form. Where the Maya turned sound into science, the Aztecs would turn water into empire. At dawn, the mist over Lake Texcoco ripples like liquid silver. The air hums with stillness, and then, from the fog, rises a vision that once left the first Europeans speechless. A city of stone and colour floating upon water, its temples glowing in the sunrise. To the soldiers of Cortes, it was not a city at all, but an illusion. A dream of glass and gold reflected in the lake. This was Tenochtitlan, the capital of the Mexica, whom history remembers as the Aztecs. To imagine it is to imagine Venice, multiplied by empire. 4 vast causeways link the island city to the mainland, each more than 5 kilometres long and wide enough for armies to march. Retractable bridges could be raised to isolate the city in times of siege. Within its watery web, an entire civilization moved in rhythm. Canoes gliding through canals, merchants trading at floating markets, priests watching the heavens from towering temples. At its height in the early 16th century, over 200,000 people lived here, more than in Paris or London at the same time. From above, it must have looked like a cosmic mandala, a symmetrical masterpiece of light and reflection. Tenochtitlan was built not upon solid ground, but upon an artificial island. The Mexica chose the center of the shallow lake for spiritual reasons. Legend told that their god Huitzilopochtli commanded them to settle where they found an eagle perched on a cactus, devouring a serpent. They did, and from that vision came both their city and the modern symbol on the flag of Mexico. But myth was only the blueprint. Engineering made it real. The Aztecs turned water, mud, and vegetation into architecture. Their greatest innovation was the chinampa, a floating garden that transformed the lake itself into farmland. Each chinampa was built by driving stakes into the lake bed, weaving reeds and branches between them, and piling mud from the bottom until it rose above the surface. These islands were typically 30 by 2.5 metres and separated by narrow canals navigated by canoe. Willow trees were planted along the edges, their roots stabilizing the soil. The result was a self-irrigating, self-renewing agricultural system capable of producing up to 7 harvests per year, an efficiency unmatched until modern hydroponics. The Chinampas sustained the empire, feeding hundreds of thousands with maize, beans, amaranth, squash, and flowers. They were a living example of sustainable design, recycling organic waste, preserving biodiversity, and maintaining constant moisture levels naturally. Fresh water flowed in through aqueducts that stretched for kilometers, channeling springs from the surrounding mountains. The most famous, the Chapultepec Aqueduct, used twin stone pipelines to deliver clean water to the heart of the city, while the polluted or brackish zones of the lake were separated by a network of dikes and sluices. The Nezahualcoyotl dike, named after the philosopher king of Texcoco, divided the salty and fresh parts of the lake, preventing contamination and controlling floods, a feat of hydraulic engineering centuries ahead of its time. Yet the Aztec science was not limited to the physical. They understood the power of sound, light, and fear. Among their most unsettling artifacts is the death whistle, a small clay instrument shaped like a skull. When blown, it produces a piercing, human-like scream that reverberates through the air. Modern reconstructions confirm its eerie accuracy. Played by hundreds of warriors at once, the sound becomes an acoustic weapon, disorienting enemies and igniting terror. Other interpretations suggest it was used during funerals, a sonic guide for souls traveling to the underworld. Whatever its function, it demonstrates the Aztecs' understanding of psychological resonance, turning ritual into technology. At the center of this watery cosmos stood the Templo Mayor, a twin pyramid rising 60 meters high, dedicated to Huitzilopochtli, god of war, and Tlaloc, god of rain. On the equinox, the sun rose exactly between its two towers, splitting light and shadow in perfect balance, the axis of heaven and earth. This precision was no accident. The Aztecs were meticulous astronomers. Their calendrical system rivaled that of the Maya. A 365-day solar cycle, Xiuhpohualli, interlocked with a 260-day ritual cycle, Tonalpohualli. Every 52 years, these two calendars completed a full rotation, the end of one cosmic era. On that night, all fires across the empire were extinguished. Priests watched the sky from the Hill of the Star until the Pleiades reached the zenith. Then upon the chest of a sacrificed warrior, they lit a new fire, symbolizing the rebirth of the cosmos. Flames from this fire were carried to every corner of the empire, rekindling hearths, temples, and cities. It was not superstition, it was synchronization, a civilization aligning itself to celestial time. Their medicine reflected the same harmony. Aztec codices such as the Badianas manuscript list over 200 medicinal plants. Arnica for wounds, chicolote for pain, quapatli for digestive ailments, cacao for the heart. Physicians performed minor surgeries, set broken bones, and used obsidian scalpels sharper than modern steel. They observed the pulse and believed disease came from imbalance between hot and cold forces, an early holistic model of health. Many of their remedies were so effective that Spanish colonists later adopted them into European medicine. Knowledge for the Aztecs was sacred. They did not write with alphabets but painted with symbols. In codices made from deerskin or agave bark, scribes recorded tribute lists, astronomical data, genealogies, and myths using pigments that still retain their color today. Each image was both art and data, a living network of memory. When the conquistadors burned these books, they did not simply destroy texts, they erased the mind of an empire. Only a few, like the Codex Borgia and Codex Mendoza, survived to hint at what was lost. The blueprint of a civilization that saw reality as interconnected circuits of spirit, sky, and soil. Tenochtitlan's planners merged ecology with theology, science with symbolism. Their city was a living map, a mirror of the stars above and the waters below. Each temple, each canal, each marketplace was placed in deliberate correspondence to cosmic order. And like so many before them, they carried a memory of the flood. Their myths spoke of Aztlan, the place of whiteness, a paradise from which their ancestors had journeyed after a great deluge. Was Aztlan a real homeland, perhaps a flooded region along the Gulf Coast, or a mythic remembrance of a lost world beneath the sea? We cannot know, but the story echoes the same motif heard across civilizations: destruction, rebirth, inheritance. The winds of Sindh and Punjab sweep across a landscape of quiet ruins. Baked brick walls half buried under centuries of dust, their edges softened by time. Here, in what is now Pakistan and northwestern India, lies one of humanity's greatest enigmas, the Indus Valley civilization. A culture so advanced, so precisely ordered, and so peaceful in appearance that it seems to have sprung into existence fully formed, then vanished without a sound. Between 2600 and 1900 BCE, while Egypt raised its pyramids and Mesopotamia built its ziggurats, the Indus world stretched across an immense territory, from the Makran coast of the Arabian Sea to the foothills of the Himalayas, from modern-day Gujarat to the plains of Afghanistan. It covered nearly 1 million square kilometers, larger than Egypt and Mesopotamia combined. And yet, its cities shared the same layout, measurements, and design principles, as though conceived by one collective mind. The Indus builders worked in uniform bricks, each in a perfect 1:4 ratio, used from one end of the civilization to the other. Their cities followed a strict grid system, streets running north-south and east-west, intersecting at right angles. Beneath these streets ran an astonishing network of drainage channels, brick-lined and covered with removable slabs for maintenance, the earliest organized sewage system known to archaeology. In Mohenjo-Daro, the Mound of the Dead, visitors walk among remains that still reveal the rhythm of daily life. Every house, whether humble or grand, had its own bathroom and private well. Wastewater flowed through terracotta pipes into the main sewers. Some homes had 2 stories, their bricks meticulously bonded with gypsum mortar. At the city's centre stood the Great Bath, a massive public tank measuring 12 by 7 metres, lined with waterproof bitumen and fed by a sophisticated drainage system. It was not just a place of cleansing, but of ritual, a fusion of hygiene and spirituality unmatched in the ancient world. To the north, the city of Harappa mirrors the same perfection: identical bricks, standardized street widths, and a layout oriented to cardinal directions suggest a centralized planning authority, not of kings or priests, but of engineers. Even their weights and measures were standardized across thousands of kilometers. Cubical stones of chert, marked with uniform increments, show a decimal system based on multiples of 10, a mathematical elegance long before the concept of zero emerged in India. Yet for all their sophistication, the Indus people left behind no palaces, no pyramids, no statues of rulers or gods. There are no war chariots carved in relief, no triumphal inscriptions. Their power was not monumental, but systemic. Their governance seems to have flowed through design, not decree, through the logic of water, grain, and brick. Archaeologists have unearthed thousands of seals, small square tokens carved from steatite, often engraved with animals, elephants, tigers, unicorn-like bulls, and rows of delicate symbols. These symbols, numbering about 400, form a script that remains undeciphered. Some seals show a seated yogic figure, surrounded by animals, in a pose strikingly similar to later depictions of Shiva as Pashupati, Lord of Beasts. Are these coincidences or the seeds of later Indian spiritual iconography? Linguists debate whether the script encodes a language or a symbolic data system, compressing economic and cosmic information into images, an ancient precursor to digital shorthand. And there is the most haunting mystery: their silence in war. Archaeological evidence reveals almost no weapons beyond simple hunting tools. Fortifications are rare, and mass graves of violent death are virtually absent. Unlike the empires of Mesopotamia or Egypt, the Indus world seems to have known peace for centuries. Was this the product of enlightened governance, or simply the illusion of an unfinished story erased by time and flood? The end, when it came, was quiet, a fade, not a fall. Around 1900 BCE, climate studies suggest that monsoon patterns shifted, turning fertile floodplains into dust and forcing rivers like the Saraswati to dry or change course. Without their lifelines of water, the cities slowly emptied. Populations migrated eastward toward the Ganges, where new settlements emerged, smaller but carrying echoes of their ancestors' precision. And yet, the Indus legacy did not die. It transformed. In the hymns of the Rig Veda, one of the oldest sacred texts known, there are references to 7 sacred rivers, to the Saraswati as the mother of floods, to cities aligned with cosmic order. The Vedic fire altars follow geometric ratios almost identical to the proportions used in Indus architecture. From these echoes emerged the Vastu Shastra, the ancient Indian science of architecture, which still governs the design of temples and homes today, blending geometry with cosmic harmony. Even India's later architectural marvels, the stepwells of Gujarat, the gridded city of Jaipur, the mandala-like temples of Khajuraho, carry the same DNA of order, proportion, and water management first seen at Mohenjo-Daro. Their engineers had understood something timeless, that civilization endures not by conquering nature, but by cooperating with it. Modern satellite imaging has revealed hundreds of unexplored sites along the ancient Saraswati's dry bed, now buried beneath sand and farmland. Archaeologists believe that these mounds, when fully excavated, could double or triple our understanding of this forgotten world, perhaps even yield the first bilingual inscription that unlocks their script, as the Rosetta Stone did for Egypt. Until then, the Indus remains the most silent of the great civilizations, its voice hidden in unbroken seals, its wisdom encoded in geometry, its philosophy whispered through the rhythm of bricks and drains. In an age obsessed with monuments to power, they built monuments to function. They proved that order itself can be sacred, that the truest technology is balance. Far to the east, under another sky, another civilization would soon take that same principle, the marriage of observation and harmony, and extend it to the heavens. Where the Indus had measured rivers, these new engineers would measure earthquakes and stars. The torch of silent precision would pass to ancient China, and the rhythm of civilization would continue. When the morning mist rises over the Yangtze Valley, it curls through the bamboo like the breath of forgotten gods. The land glows with dew and silence, mountains wrapped in cloud, rivers winding like veins of silver. Beneath these mists lie ruins older than empires, quarries, observatories, and stone altars carved straight from the bones of the earth. Here, in ancient China, the line between science and mysticism vanished. To the Chinese mind, the universe was not a place to be conquered. It was a living pattern to be harmonized. The cosmos was a mirror of the human spirit, and to understand it was to align with its rhythm. Near the city of Nanjing, a mysterious monument still whispers of this forgotten mastery, the Yangshan Quarry. 3 immense stone blocks remain half-cut from the mountainside, their faces gleaming smooth as metal. The largest weighs an estimated 16,000 tons, more than 10 times the stones of Baalbek. Why were they carved and why were they left behind? No ancient text records the reason. Historians have speculated that the stones were intended for a Ming dynasty mausoleum, yet their size exceeds any known method of transport, ancient or modern. Some researchers suggest that the stones were never meant to move at all. Perhaps they served as calibration models, an experimental megalithic laboratory where builders studied mass, vibration, and equilibrium. This fascination with balance was not unique to the quarry. It defined all of early Chinese technology. Their inventions were never merely mechanical, they were expressions of natural law. During the Han Dynasty, the polymath Zhang Heng built an instrument that astonished later generations, the world's first seismoscope. A bronze vessel adorned with dragons and toads, it stood like a silent guardian in the imperial court. When an earthquake occurred, hundreds of kilometers away, one dragon would release a bronze ball into the open mouth of a frog, indicating the direction of the tremor. Inside, pendulums and levers translated invisible vibrations into movement, a machine sensitive enough to detect quakes no human could feel. Modern engineers have reconstructed Zhang Heng's device, and it works. Over 1,800 years before modern seismology, Chinese science had already learned to listen to the Earth's heartbeat. But the gaze of China's scholars was not fixed on the ground alone. It stretched upward to the heavens. In 100 BCE, astronomers constructed the armillary sphere, a nested system of bronze rings modelling the movement of the stars. It was not simply an instrument, but a philosophical diagram, a model of the cosmos in perfect mechanical balance. As its rings turned, it mirrored the rotation of the celestial sphere, tracking the positions of the sun, moon, planets, and constellations. Later, during the Tang and Song dynasties, these devices evolved into intricate astronomical clocks, some powered by water wheels and escapement gears, centuries before similar mechanisms appeared in Europe. The same quest for harmony guided China's greatest discoveries, inventions that shaped the world itself. In the 2nd century CE, Kailasa revolutionized civilization by inventing paper. By pulping tree bark, hemp fibers, and fishing nets, he created a surface lighter and more adaptable than silk, one that could carry words across distances and centuries. From this invention flowed the entire machinery of memory: books, bureaucracy, maps, and art, all the written voices of humanity that would have been impossible without those thin white sheets. Then came gunpowder, born not from war, but from alchemy. Taoist monks, seeking elixirs of immortality, mixed sulfur, saltpeter, and charcoal, and discovered instead the fire of heaven. At first it was used for ritual fireworks, to celebrate the movement of stars and ward off evil spirits. Only later did it become a weapon, turning divine spectacle into conquest. Even destruction in its beginning had been an act of devotion. In the same centuries, another invisible force was discovered: the Earth's own pulse. By observing magnetite, a naturally magnetic stone, Chinese philosophers realized it could orient itself toward a constant direction. They floated it in water or suspended it on silk, creating the world's first compass. But before it guided sailors across oceans, it guided architects and emperors. The compass was first a tool of feng shui, used to align tombs, homes, and temples with the unseen forces of wind and water. Each construction, from the forbidden city to a humble dwelling, was laid out according to the magnetic flow of qi, the life energy that connected heaven and earth. These discoveries, paper, gunpowder, compass, seismoscope, are often called the 4 great inventions. But in truth, they were not 4 isolated sparks, they were one continuous fire, the pursuit of balance between the visible and the invisible. Even Chinese metallurgy reflected this harmony. The technique of cast iron, developed centuries before Europe, allowed them to pour molten metal into molds, creating objects of exact proportion: bells, cauldrons, and statues that sang when struck. Archaeologists have found bronze mirrors polished so finely they still reflect with clarity after 2,000 years. Some bear concentric patterns that, when illuminated by sunlight, project intricate designs onto the walls. optical technology hidden in art. For the ancient Chinese, knowledge was never separate from virtue. Every invention carried moral weight. The philosopher Laozi wrote, "To master the world, one must act in accordance with its flow." Their scientists did not seek to dominate nature, but to become part of its current, engineers of balance, not control. It is tempting to see these as miracles of invention, but perhaps they are something else. Remembered laws, rediscovered from a much older tradition of cosmic observation. After all, the same geometric precision seen in Chinese observatories appears in the pyramids of Egypt, in Sumerian ziggurats, in the sun temples of the Andes. Each culture, separated by oceans, found the same relationship between shape, sound, and the sky. Could this be coincidence or continuity? Were these not inventions but echoes of an ancient science that once spanned the globe? The air at 4,000 meters is thin enough to shimmer. Each breath tastes of altitude and silence. Here, on the Altiplano of Bolivia, where the Andes flatten into a cold ocean of light, the wind seems to hum across the ruins of Tiwanaku, a city built at the edge of the sky, where stone, sound, and sunlight merge into one. This was not a mere settlement. It was the axis of an ancient world, older than the Inca, and perhaps older than the historical timeline itself. Archaeologists date its origins to at least 1500 BCE, but radiocarbon tests and geological studies hint that the earlier structures may be far older, built during a climate when Lake Titicaca's waters were higher, lapping against the very walls of the city. At its heart lies Pumapunku, the Gate of the Puma, one of the strangest and most precise stone complexes ever discovered. Scattered across the plateau are blocks of andesite and red sandstone, each weighing between 100 and 130 tons. Some bear the unmistakable geometry of H-shaped cuts, their angles measured in fractions of a millimeter. Drill holes, straight grooves, and interlocking notches appear as though shaped by machinery. Yet no metal chisels, no wheels, no draft animals have ever been found. Andesite is one of the hardest stones on Earth, second only to granite, yet the surfaces here are smooth, symmetrical, and perfectly parallel. Archaeologists, engineers, and skeptics alike have stood before these stones in disbelief. Conventional theories suggest that stone tools and sand abrasion could have achieved this precision, but experiments have struggled to replicate the results. The more we measure Tiwanaku, the more it resists simplicity. To the Aymara people, who still live on the high plains, the story is far older than any textbook. They say these stones were sung into place. Their ancestors spoke of Viracocha, the white-robed god who emerged from the waters of Lake Titicaca after the Great Flood. He brought with him light, mathematics, and the arts of civilization. When his work was done, he walked west across the sea, promising to return. Whether myth or memory, the legend carries an echo of lost technology, knowledge that could make stone vibrate and move as if it were light. Recent studies lend subtle weight to this ancient intuition. Acoustic engineers examining Kailasa, Tiwanaku's great temple enclosure, have recorded resonant frequencies that amplify specific tones. When sound is produced at particular pitches, the air between the stone pillars oscillates, creating audible standing waves. The arrangement of walls, corners, and chambers seems designed not only for alignment with the solstices, but also to control vibration, to turn architecture into an instrument. The gateway of the sun, carved from a single 10-ton block of andesite, is more than an archway. Its lintel bears an intricate relief of the solar deity, surrounded by 48 winged figures and 11 smaller icons, thought by some to represent the months or cycles of the year. The carving is both art and astronomy, a calendar etched in stone, calibrated to the solstices and equinoxes. At dawn on the winter solstice, sunlight passes directly through the gate, striking an altar once used for offerings. proof that Tiwanaku's builders were synchronizing human ritual with celestial precision. Their mastery wasn't confined to stone. Metallurgy at Tiwanaku reached levels rarely seen in the ancient world. Alloys of copper, tin, and arsenic were produced in controlled furnaces, giving rise to a kind of early bronze long before its appearance elsewhere in the Americas. These metals were not merely decorative, they were structural. Small eye-shaped clamps, cast from bronze, were used to join massive stone blocks together, an innovation so effective that the technique would not be rediscovered until modern architecture. Archaeologists have found moulds, smelting sites, and slag deposits, suggesting a complex industrial system powered by charcoal and airflow control, perfectly suited to the high-altitude winds. Even agriculture here was a science of balance. The Altiplano is a place of extremes, frost by night, blazing sun by day, yet Tiwanaku's engineers invented the waru-waru system, a network of raised planting beds surrounded by water channels. During the freezing nights, the water absorbed heat and released it slowly, keeping crops from dying. In the morning, the channels reflected sunlight, increasing photosynthesis. This biothermal regulation allowed the people to farm potatoes, quinoa, and maize in one of the world's harshest environments. Satellite imagery has revealed that thousands of hectares of these raised fields still trace the landscape, remnants of what may be the first example of climate-adaptive farming on record. Everything in Tiwanaku was constructed as an act of equilibrium, light and shadow, water and air, tone and mass. Its temples, statues, and canals form geometric ratios that mirror those found in music, the same harmonic proportions used in the tuning of instruments. Standing within Kailasa at sunrise, the air seems to hum faintly, a resonance that many travellers have described but few can explain. Perhaps it is wind, or perhaps, as the Aymara elders say, the stones still sing the frequencies of their creation. Modern archaeologists date the fall of Tiwanaku to around 1000 CE, likely due to drought and climate change. But the precision of its design, the mathematical elegance of its carvings, and the sheer scale of its monuments point to something more. A knowledge system that saw architecture as living vibration, not mere construction. If this civilization truly harnessed the power of sound and geometry, it may represent a fragment of an older scientific tradition, one shared with other ancient sites across the planet. The pyramids of Giza, Baalbek's terraces, the ziggurats of Sumer. Each reveals the same mysterious fingerprint, resonance encoded in stone. The heat of Rajasthan shimmers like glass, rippling above the ochre sands. Beneath that shimmering air, hidden within the earth, geometry breathes. At Chand Baori, more than 3,500 steps descend into the cool shadow of a well so deep that sound seems to vanish halfway down. Built over 1,000 years ago in the town of Abhaneri, it is one of the largest and most perfectly symmetrical stepwells in the world, an architecture of both necessity and meditation. From the surface, it appears like an inverted pyramid carved from stone, each stair a line in an equation of survival. In the desert, where water is sacred, Chand Baori was both a reservoir and a cathedral. Its design captures thermal gradients so precisely that the air at the bottom remains 5 to 6 degrees cooler than the scorching temperature above. Rainwater descending the steps would cool and collect, while the vast geometric surfaces minimized evaporation, a marvel of environmental engineering long before the word existed. Standing at the bottom, surrounded by endless triangles of light and shadow, one feels the presence of something greater, a structure that measured not only water but time itself. Ancient India's technology was never purely mechanical. It was spiritual engineering, a union of mathematics and metaphysics. At its heart was Vastu Shastra, the science of spatial harmony. It taught that every building, from temple to dwelling, must reflect the geometry of the cosmos. Orientation, proportion, and symmetry were not aesthetic choices, but acts of cosmic balance. The position of the door, the direction of a staircase, even the ratio of width to height, all were calculated to align with the flow of energy, or prana. This philosophy reached its zenith not in the desert, but deep in the basalt cliffs of Maharashtra. Here, at Ellora, an entire mountain was carved into the Kailasa temple, a monument that redefined human capability. Unlike the pyramids of Egypt, built block by block, Kailasa was sculpted from the top down, cut directly out of the mountain as one single piece of living rock. Over 200,000 tons of basalt were removed, yet no trace of debris large enough to account for that excavation has ever been found. How the workers planned the excavation remains one of the great mysteries of ancient engineering. The entire complex, temples, corridors, columns, sculptures, and shrines, maintains flawless vertical alignment, as though the mountain itself were peeled away with invisible precision tools. Archaeologists estimate it took several generations to complete, yet every detail suggests the mind of a single master architect. The carvings reveal three-dimensional symmetry, repeated across vertical and horizontal planes. Pillars align through multiple floors with an error margin smaller than that of many modern buildings. Some engineers compare it to the precision of laser cutting, each stroke of the chisel guided by mathematical vision rather than improvisation. Every element of Kailasa was built with symbolic geometry. The temple represents Mount Meru, the mythic axis of the universe, its summit touching heaven, its base rooted in the underworld. To enter the temple is to move through creation itself, from the outer chaos of the world to the stillness of the divine center. Viewed from above, its proportions mirror a mandala, the sacred diagram of the cosmos. Every curve and corridor echoes the rhythms of Sanskrit chants, as though vibration itself shaped the stone. India's fascination with pattern extended from architecture into mathematics. Millennia before modern calculus, Indian thinkers had already grasped the infinite. The mathematician Aryabhata, 5th century CE, described the rotation of the earth and calculated pi to 4 decimal places. Brahmagupta formalized the rules of arithmetic involving zero, redefining it not as emptiness but as potential, a seed from which all number emerges. This philosophy of shunya, void as possibility, echoed the spiritual principle that creation arises from silence, just as geometry arises from the point. In the ancient observatories of India, that principle became tangible. The Jantar Mantar of Jaipur, built in the 18th century by Maharaja Jai Singh II, may seem younger than the civilizations of Ellora or Chandbaori, but its roots stretch back to the same cosmic geometry. Each instrument, massive arcs and towers of stone, measures celestial motion using pure geometry. The Samrat Yantra, a sundial over 27 meters high, tracks the sun's shadow with a precision of 2 seconds. The Jai Prakash, a bowl-shaped structure, projects the sky onto its interior walls, allowing astronomers to read the heavens like a map laid at their feet. These instruments, made of stone rather than metal, represent the culmination of a tradition that saw time as architecture, the cosmos rendered in form and shadow. Even India's legends speak the same mathematical language. The ancient Sanskrit epics describe the Vimanas, flying chariots driven by sound, mercury, and light. In the Samarangana Sutradhara, an 11th century treatise on architecture and mechanics, detailed descriptions of machines that fly by fire and wind appear alongside designs for rotating temples and automated doors. Whether metaphor or memory, these texts show a civilization deeply aware of mechanical principles, energy, and vibration, centuries before such knowledge was formally recorded elsewhere. To India's builders, geometry was devotion. Every stone, every ratio, was a prayer inscribed into matter. Temples were not only houses of gods, but also machines of consciousness, structures designed to focus energy and align human awareness with the universal order. When one chants within the halls of Kailasa or walks the steps of Chand Baori, the sound and shape merge. Vibration becomes architecture. Even today, India's architecture continues to embody these principles. The stepwells of Gujarat, the water temples of Hampi, and the symmetrical gardens of the Mughal era all reflect the same cosmic blueprint, where geometry, water, and light converse in eternal dialogue. Each structure is both practical and poetic, cooling systems, observatories, and art all folded into a single living design. Perhaps these monuments were not simply acts of devotion, but repositories of encoded knowledge, blueprints left behind by civilizations that understood how energy moves through form. From Chandbaori's cooling symmetry to Kailasa's carved mountain, India's builders left us not ruins, but equations written in stone. Far out in the Pacific, where the horizon curves like a ring of endless blue and clouds drift like slow ships of memory, lies an island smaller than a city but older than legend. Rapa Nui, the world calls it Easter Island, stands as one of the most mysterious dots on Earth's map. A volcanic fragment adrift between sea and sky, it is the last whisper of a drowned continent, a world unto itself. And yet here, isolated by thousands of kilometers of ocean, ancient hands created one of humanity's most haunting legacies, the Moai, towering stone figures with faces of solemn grace and eyes of coral that once stared not toward the sea, but inward, toward their people. Nearly 900 statues are scattered across this small island, some standing upright on stone platforms called ahu, others lying half-buried in the slopes of the quarry at Rano Raraku, as though frozen mid-creation. The tallest, known as Paro, once rose over 10 meters high and weighed more than 80 tons. Many others rest unfinished in the volcanic tuff, their heads emerging from the earth like dreams half-remembered. To the Rapa Nui people, these were not idols, but ancestors. Each Moai embodied the spirit of a chief or a revered elder, channeling mana, sacred energy, life force, and authority. Their placement along the island's perimeter symbolized protection. Every statue faced inward, guarding the living, not watching the sea. For centuries, the mystery of Rapa Nui centered not on why the Moai were made, but how they were moved. The island, only 24 kilometers wide, has no trees large enough for rollers and no animals to pull them. How then did the Rapa Nui transport these monoliths, some weighing more than a jet airliner, across miles of uneven ground? Early explorers imagined sledges, ropes, or even supernatural levitation. But the island's deforestation made such theories improbable. Then came a revelation. In 2013, archaeologists Carl Lipo and Terry Hunt, working alongside Rapa Nui elders, tested an old oral tradition that the statues had walked to their resting places. Using 3 teams of people and long ropes attached to a replica Moai, they pulled and released in rhythmic motion, left, right, left. To everyone's astonishment, the statue began to walk upright, swaying side to side like a living being. It was not brute force, but balance, not engineering in the mechanical sense, but choreography. Rapa Nui's ancestors had mastered vibration and center of gravity intuitively. Their technology was song, the movement required harmony, the push and pull of bodies guided by rhythm and chant, transforming the impossible into a communal ritual of physics and faith. This idea of rhythm as technology echoes across the ancient world. At Tiwanaku in the Andes, the builders shaped stones with resonance. At Egypt's temples, chants amplified architecture. Here, in the middle of the Pacific, the same principle returned in living form. Energy directed through harmony. Even the placement of the Moai followed cosmic order. Many Ahu platforms align with astronomical and navigational points. The great Ahu Tongariki, for example, faces the sunrise of the southern solstice, its 15 statues illuminated in sequence as the first light crosses the horizon. Other platforms align with lunar standstills or the rising of Canopus, a guiding star used by Polynesian navigators. To the islanders, the sky was a map, the land its reflection. The Moai were not merely monuments, they were celestial markers, stone calendars linking the cycles of heaven to the pulse of the earth. And then there are the Rongo tablets, slender wooden boards covered with looping, elegant glyphs of humans, birds, and abstract symbols. Discovered in the 19th century, they represent the only known independent writing system in the entire Pacific. No one has yet deciphered them. Each line must be read in reverse boustrophedon, turning the tablet upside down at the end of each row, following the text like a serpent winding through time. Some scholars believe the glyphs record genealogies or hymns to the gods. Others think they encode astronomical data, perhaps instructions for navigation or the timing of rituals. If the secret of Rongo is ever unlocked, it could rewrite the history of literacy and human thought, proof that writing can emerge even on the most remote island, born from memory alone. But the story of Rapanui carries another, darker resonance, one not of triumph, but of warning. As the population grew and resources dwindled, trees were felled faster than they could regrow. The soil eroded and the ecosystem collapsed. Without timber for canoes or fire, the people turned inward, and the society that once moved mountains with song fell into division and hunger. When European ships arrived in the 18th century, they found a devastated landscape. The Moai toppled, their faces buried, their mana silenced. Later, slave raids and introduced diseases nearly extinguished the culture entirely. Across continents and centuries, the fragments begin to connect, a global web of stone and silence. Each culture built differently, yet everyone seems to echo an ancient blueprint, a shared code of geometry, water, light, and endurance. In this web, the traces of lost mastery are not confined to one land. They appear everywhere, from the deserts of Arabia to the mountains of Anatolia, from the valleys of Mexico to the marble halls of Rome. In Jordan, the Nabateans turned one of the driest deserts on earth into a city of flowing water. Petra, the Rose City, is carved directly into sandstone cliffs, its facades glowing red at sunset as if lit from within. The builders worked from the top down, chiseling temples, tombs, and theatres out of the living rock. But the true marvel lies beneath, a network of dams, cisterns, and channels that captured every drop of rain, filtered it through sediment basins, and stored it for years. Even through drought, Petra's fountains ran. They made coolness in heat, life from dust, a kind of reverse alchemy. To the west, in Lycia, high on the cliffs of Anatolia, an equally astonishing tradition took form. Tombs carved into mountainsides, some perched 50 meters above the ground. They were houses for the dead, shaped like homes for the living, complete with doors, beams, and columns sculpted from single blocks. How were such tombs carved with such precision at such heights? Rope scaffolds? Pulley systems? Or something else? The Lycians understood the psychology of eternity. To carve upward was to ascend toward the gods, to make the mountain itself an afterlife. Across the ocean, in Mexico's Oaxaca Valley, the Zapotecs flattened an entire mountaintop to build Monte Alban, a city that seems to float above the clouds. Without iron tools or animals, they moved millions of tons of earth and stone, creating terraces, pyramids, and observatories aligned to solstices and equinoxes. The entire city was an instrument, a mountain tuned to the sun. In Persia, the empire of Cyrus and Darius extended this idea into administration and ecology. Their royal road ran more than 2,500 kilometers, uniting provinces across mountains and deserts. Messengers could cross the empire in a week, a living network of communication. In their desert cities, they built badjirs, or wine towers, which captured high air currents and funneled them into homes, cooling by evaporation. It was air conditioning by design, centuries before electricity, technology woven with grace. At Persepolis, columns rose like forests of stone, carved with processions of nations bringing tribute. The walls shimmered with polished reliefs that seemed to breathe sunlight. Their geometry followed astronomical ratios. Their timekeeping followed the Zoroastrian calendar, a model of solar precision. For the Persians, order was not merely political, it was cosmic. In the Assyrian heartland, technology took the form of intimidation and control. Colossal lamassu, winged bulls with human faces, guarded gateways carved from single stones weighing 30 tons. These guardians were more than symbols. They were proof of engineering capable of transporting and setting such masses with perfect symmetry. Behind them stretched canals, gardens and cities irrigated by aqueducts rivaling Rome's. A reminder that Mesopotamia, the land between rivers, was also the land between myth and machine. And before the Assyrians came the Sumerians, the first to shape time itself. They divided the day into 24 hours, the circle into 360 degrees, the minute into 60 seconds, numbers we still use, inheritors of their measure. Their ziggurats reached upward as layered mountains, built from clay and cosmic order. Their cuneiform tablets recorded astronomy, law, and memory. The Code of Ur-Nammu codified justice millennia before Rome, proof that technology can also be ethical, a system to organize not stone but society. Rome, in turn, turned these foundations into empire. Their concrete mixed with volcanic ash remains unmatched in longevity, still stronger today than many modern formulations. Their aqueducts carried clean water for miles. Their roads stretched 400,000 kilometers, connecting provinces with mathematical regularity. Their architecture married function and spectacle. The Pantheon's dome floats like a concrete sky. The Colosseum's acoustics still carry a whisper to the farthest seat. Meanwhile, the Phoenicians mastered the sea. Their ships, built with double prows, could reverse direction instantly, a design unknown elsewhere. They followed the stars, Sirius, Canopus, Ursa Major, using celestial navigation that predated compasses. And from their ports came the alphabet, a system of 22 phonetic signs that gave voice to the world. As Rome fell, the Byzantines kept its flame. In Constantinople, engineers forged Greek fire, a weapon that burned even on water, chemistry so advanced it remains unsolved. Their Hagia Sophia suspended a dome larger than imagination, floating on light that poured through hidden windows, dissolving stone into air. And in the mountains of Pontus, the monastery of Sumela clung to sheer cliffs, an impossible feat of design, rising 1,200 meters above the valley floor, stone reaching for heaven. Across all these empires, a single pattern persists: technology as reverence. Whether in water, air, fire, or stone, each culture sought not domination, but balance, a way to live within the laws of earth while reaching toward the divine. It is as if every civilization remembered one fragment of an older whole. Petra preserved the knowledge of water, Sumer, the measure of time, Rome, the mastery of form, India, the language of number, China, the order of heaven. Each was a node in a network stretching across millennia, a web of memory vibrating beneath history's surface. But if these fragments belong to the same lost inheritance, then the question becomes, where did it begin? What pulse once moved through these empires? A rhythm older than history, buried yet unbroken? Perhaps if we listen closely, the earth still hums with that frequency, waiting for us to remember. The story of human civilization, as we have told it, runs in a straight line, from primitive caves to pyramids, from bronze to silicon. But when we look closely, the line bends, loops, folds into itself like an ancient spiral. It is not progress, but remembrance. Beneath every ruin hums the same question: what came before? Across continents the echoes align: megaliths built with impossible precision, myths of gods who walk the earth, floods that reset time itself. The same numbers, same ratios, same alignments repeat across ages and oceans, as though humanity keeps awakening to the same forgotten pattern. What if these repetitions are not coincidence, but continuity? What if civilization is not a series of beginnings, but a sequence of recoveries, each rediscovering a little more of what was lost? Geologists reading the rocks of the Younger Dryas find evidence of global fire and flood: nanodiamonds, melt glass, shocked quartz, traces of a cosmic impact that nearly ended life 12,800 years ago. Myths remember it as the flood, the fall, the age of darkness. But buried within those stories are blueprints, sacred geometry, stellar alignments, and knowledge of Earth's cycles. They whisper of a world that measured time in tens of thousands of years, not centuries. A civilization erased, but not forgotten. Even now, the ground yields fragments. Ground-penetrating radar beneath the Giza plateau reveals hidden voids, chambers where stone rings like metal when struck. In Turkey, beneath Gobekli Tepe, new layers suggest even older temples waiting in the dust. Satellite imagery across the Sahara exposes faint traces of buried rivers, arteries of green that once fed cities long lost to the sun. And in the depths of the Gulf of Cambay, off India's coast, sonar scans have found symmetrical ruins submerged beneath 60 feet of water, radiocarbon dated to a time before any known empire. Each discovery feels less like revelation and more like recognition, as if the Earth is slowly remembering itself. But perhaps the true mystery is not technological, it is biological. Genetic studies show that modern humans share unexpected markers across continents, suggesting migrations older than archaeology allows. A deep past that blurs the lines between myth and migration, between gods and ancestors. Could the gods who rebuilt after the flood have simply been the survivors, the last engineers of a vanished age, carrying fragments of memory across oceans and generations? Maybe that is why the same mind, the same hand, seems to have shaped ziggurats, pyramids, temples, and calendars, because the builders were all descendants of one forgotten lineage, a lineage not of blood, but of knowledge. If so, then technology is not merely invention, it is memory made manifest. Every bridge, every tower, every line of code, an echo of the first geometry taught beneath an older sun. When we listen to the hum of machines, the pulse of servers, the orbit of satellites, we might be hearing a familiar rhythm, the same frequency that once guided stones into alignment or stars into maps. The cycle continues, whether we know it or not. Civilization rises, falls, and rises again. Knowledge accumulates, burns, and returns. But beneath the collapse and rebirth, something remains constant: the human urge to understand, to measure, to remember. Perhaps that is the true ancient technology, not tools of metal or stone, but consciousness itself. The ability to look at the world and see pattern in chaos, to rebuild from ruin, to reach upward even when surrounded by ashes. If all our monuments were buried tomorrow, would the future know we once existed? Would they recognize our cities as we recognize Giza, Baalbek, or Tiwanaku as remnants of something greater than ourselves? Maybe, in some distant cycle, they will uncover our world, the concrete, the circuits, the satellites, and wonder how such precision could have been achieved so long ago. They will ask who we were and whether we too were guided by gods or ghosts, and perhaps the answer will be the same. We were simply remembering. So tonight, as you listen to the wind between ruins, the hum beneath the earth, and the silence between stars, remember, the pulse has never stopped. It beats through the pyramids, through the quipu, through the compass and the code. It beats in you. The story is not over. It is only folded, waiting to be opened again. Where are you listening from tonight, and at what time in history?